The process begins with flat brass sheets, chosen for their durability and resistance to corrosion. These sheets are fed into a stamping press where high-pressure punches cut and shape them into small cylindrical cups. The cups are then inspected for uniformity before moving to the next stage of production. After pressing, the metal cups undergo thorough cleaning to remove any dirt, oil, or debris. This step ensures the material is free of contaminants that could affect later stages of production, particularly the integrity of the cartridge case. Once cleaned, the cups are transformed into cartridge cases. This involves a series of mechanical operations, including deep drawing and shaping, to give them the correct dimensions. The cases are then annealed, heat-treated, to increase durability and flexibility. The primer is a small but crucial component of ammunition, responsible for igniting the gunpowder. In this stage, primers are inserted into the base of the cartridge case. The primer contains a small amount of impact-sensitive explosive material that ignites when struck by a firing pin. Bullet production begins with raw materials, typically lead for the core and copper or brass for the jacket. The lead is melted and either cast into molds or swagged compressed under high pressure into precise shapes. For jacketed bullets, a thin metal layer is drawn into a casing around the lead core, improving strength and reducing barrel fouling. Hollow points, full metal jackets, and other designs are made based on intended use. Each bullet undergoes quality checks for weight, shape, and consistency. To ensure consistent performance, bullets and powder charges are subject to strict weight control. Cartridge assembly involves carefully combining the primer, cartridge case, gunpowder, and bullet. First, the precise amount of gunpowder is measured and loaded into the case. The bullet is then seated onto the case mouth and crimped to ensure a secure fit. This step requires extreme precision to maintain consistent pressure, velocity, and overall performance in firearms. Cartridge sealing is essential for protecting ammunition from moisture, dust, and environmental factors. A waterproof sealant, such as lacquer or polymer, is applied around the primer pocket and bullet crimp. This prevents contaminants from affecting the gunpowder or primer, ensuring reliability in harsh conditions. Military and high-performance ammunition often undergo additional sealing for enhanced durability. Rifle ammunition is specifically designed for long-range accuracy, velocity, and impact. These cartridges are used by military forces, law enforcement, hunters, and sport shooters. The process begins with the melting pot billet caster, where raw lead or recycled lead is in a high-capacity furnace. The molten lead is then cast into billets of a specific size and weight. This ensures uniformity and consistency in the later extrusion process. The automation of this stage minimizes impurities and enhances the quality of the billet. Once the billets are cast, they move to the billet trimmer, where excess or irregular lead material is removed. This trimming process ensures that each billet meets the precise dimensions required for seamless extrusion. The scrap recycle elevator plays a critical role in sustainability and efficiency. All trimmed or defective lead pieces are transported via this elevator back to the melting pot, where they are remelted and cast again. The billet conveyor transports the trimmed billets to the next stage in the production line. This automated system ensures a smooth, continuous flow of billets, eliminating the need for manual handling and reducing production downtime. The conveyor is designed to integrate seamlessly with the extrusion process, improving overall efficiency. The billets are then fed into the winder and extruder, the heart of the lead wire production process. The extruder applies high pressure to the billets, forcing the lead through a die to create uniform lead wires of the required diameter. The winder ensures that these wires are coiled neatly for further processing. The precise control of extrusion parameters ensures the highest quality lead wires, crucial for ammunition manufacturing. Finally, the lead wires are processed into bullets and assembled into cartridges. The 7.62 by 51 mm linking machine takes the completed rounds and links them into belts for use in machine guns and other automatic weapons. This machine operates with high precision, ensuring that each round is securely held within metal links that maintain proper spacing and feeding reliability. The linking process is crucial for maintaining the functionality of belt-fed firearms, as any misalignment could cause jamming or misfires. The machine is designed to handle large volumes efficiently, accommodating different belt configurations required by various military and law enforcement agencies. It integrates advanced automation, reducing human intervention while increasing the speed and accuracy of the linking process. The final linked ammunition belts undergo quality control checks to ensure they meet military standards before being packaged for distribution. This step ensures that the ammunition is fully prepared for deployment in combat or training environments, offering reliability and efficiency under high-intensity conditions. CAMDEX is a leading provider of high-quality ammunition manufacturing equipment and reloading systems. Based in Troy, Michigan, the company specializes in designing and producing reliable, efficient, and durable machinery for commercial ammunition producers and law enforcement agencies. With decades of experience in the industry, CAMDEX has built a strong reputation for precision engineering and innovation. Their automated reloading systems are widely used by ammunition manufacturers seeking to enhance productivity while maintaining stringent quality standards. These machines are designed to handle a variety of calibers with speed and accuracy, ensuring consistent performance and reliability. CAMDEX offers a comprehensive range of products, including case processing equipment, loading machines, and inspection systems. Their solutions help manufacturers increase efficiency, reduce waste, and maintain compliance with industry regulations. Crane Army Ammunition Activity, CAA, is responsible for the production, renovation, storage, and shipment of munitions for the Department of Defense. The manufacturing process involves the loading and pressing of various ammunition types, including flares, illumination devices, and munitions components. CAA is a recognized leader in producing pyrotechnic devices, such as smoke and infrared flares. In addition to production, the facility handles the renovation of conventional munitions and specializes in demilitarization, safely disposing of outdated ammunition and recycling inert materials. Forging Center is a company that specializes in producing high-quality shell bodies ranging from 60 mm to 155 mm caliber. Established in 2011, the company focuses on forging parts from high-quality steel to meet the rigorous standards of various industries, particularly in defense and civil sectors. The forging process is central to the company's operations, where the steel is sourced from trusted foreign suppliers. Upon arrival at the factory, the steel undergoes strict quality checks, including unloading, preliminary measurements, and inspections to ensure the material meets the required standards. Once the steel passes the initial quality assessment, it is cut and carefully measured before proceeding to the forging stages. This involves multiple forging processes, followed by further measurements and scrutiny to maintain consistency and precision. The shell bodies then enter the mechanical department, where they undergo sandblasting and heat treatments, further ensuring their durability and integrity. The company invests heavily in state-of-the-art equipment and laboratory facilities dedicated to quality control at every step of production. With new advanced machinery, the company ensures that each shell body is produced to exacting standards. Quality control is a key differentiator for Forging Center, with specialized equipment used to monitor and verify every aspect of the forging process. 195,155 mm high explosive HE projectile is an essential artillery munition used by various armed forces worldwide. Designed to deliver effective firepower, it plays a significant role in both conventional warfare and specialized military operations. Its quality control to ensure the round performs effectively in combat. The M795 is a standard 155 mm artillery shell designed for use with 155 mm howitzers, which are commonly employed in modern artillery systems. The projectile consists of several key components: the shell body, the explosive charge, the fuse, and the driving band. The shell's body is typically made of high-strength steel or a similar alloy to withstand the immense pressure and force generated during firing. The fuse is typically a mechanical or electronic device designed to detonate the explosive charge upon impact or after a specific delay, depending on the type of fuse used. The high explosive charge inside the M795 is typically TNT or Composition B, which is a mixture of RDX and TNT. This charge is designed to produce a powerful explosion upon detonation, delivering devastating fragmentation effects that can disable enemy troops, equipment, and fortifications. The projectile can be fitted with various types of fuses, including point-detonating fuses, proximity fuses, or time-delay fuses, depending on the operational requirements. Next, the shell undergoes assembly, where the explosive filling is introduced into the casing. This is a delicate process, as the explosive charge must be accurately measured and placed inside the shell without risk of detonation. Once the explosive charge is in place, the fuse mechanism is added, which is carefully calibrated to ensure proper detonation in various conditions. The final stage of production involves testing and quality control. Each projectile is subjected to stringent tests, including pressure and safety checks, to verify that it meets the required standards for durability, performance, and safety. Additionally, the shells are inspected for any manufacturing defects, ensuring that no defective rounds are sent out for use in combat. After passing quality control, the M795 projectiles are packed, stored, and prepared for shipment to military units. The M795 heat projectile is designed to be used in a variety of tactical situations. It can be fired from a range of 10 to 30 kilometers, depending on the type of howitzer used and the charge of the propellant. The explosive force generated by the M795 is capable of causing significant damage to personnel, light vehicles, and structures. Additionally, its fragmentation effect increases its lethality, making it ideal for targeting enemy infantry and light fortifications. The journey begins with the procurement of high-quality raw materials, typically steel bars that are specially rolled at a steel mill. These bars are designed with specific mechanical properties, making them ideal for firearm production. The first stage in barrel manufacturing is cutting. The steel bars are loaded into a cutting machine, which carefully slices them into the required lengths. Precision is critical in this stage to ensure that both ends of the cut are perfectly perpendicular to the bar's axis, as this affects the overall barrel geometry. Once the bars are cut, they move on to the drilling stage, where they are drilled to the required diameter. For smooth barrels, the holes are relatively large, while rifled barrels require much smaller, more precise holes. Specialized tools like cannon drills are used to ensure the deep, precise holes required for proper barrel function. Next, the barrels are placed on CNC lathes to begin the process of shaping. During this phase, the external profile of the barrel is created. A centering collar is added to ensure concentricity, both internally and externally, which is crucial to maintain uniform thickness along the entire barrel length. Achieving the right balance of thickness ensures the structural integrity and accuracy of the barrel. After lathing, the barrel undergoes an external polishing operation. The initial polishing smooths the surface, but the barrel will be polished multiple times throughout the process to reach the desired finish. The most intricate part of the process occurs in the internal polishing stage, especially for rifled barrels. The internal surface of the barrel must be smooth and free of defects to maintain the accuracy of the firearm. This operation is delicate, and the precision with which it is done is vital for the firearm's overall performance. The internal surface is carefully polished, and the final quality check ensures the barrel is ready for the next step. Once the barrel has been shaped and polished, the next operation is engagement and fitting. In this stage, the barrel's connection points are rectified. Unlike many other manufacturers, the SABATTI factory uses a slightly conical modification for the engagement, ensuring a slight interference fit between the barrel and its mating components. This interference creates a stronger bond between the parts and contributes to the overall performance and durability of the firearm. The rifling process follows, where the internal grooves, rifling, are added to the barrel. This is done through a hammering process where a hammering pin is coated with lubricant to prevent jamming and then inserted into the barrel. The external shape of the barrel is deformed to match the pattern of rifling required for accurate shooting. The rifling is then imprinted onto the internal surface of the barrel, ensuring the proper pattern to spin the bullet as it travels down the barrel. Finally, the barrel undergoes inspection and quality control. The rifling and dimensions are checked for accuracy, and any potential defects are carefully examined. Once all the operations are complete, additional steps like threading and chambering are performed, ensuring the barrel fits seamlessly with other firearm components, such as the receiver. In the woodworking and sanding process, the stock, the wooden part of the rifle, is carefully shaped to fit the firearm's action precisely. Initially, rough cuts are made to the wood to form the general shape of the stock. Then the sanding process begins, gradually smoothing the surface and ensuring the dimensions are accurate. This involves multiple stages of sanding with progressively finer grit sandpaper. The goal is to create a perfectly fitting stock that aligns with the action, providing stability and comfort. After shaping, the stock is finished with either varnish or oil, which enhances its appearance, protects the wood, and preserves its durability. The welding and polishing process is a crucial step in the production of high-quality firearms, particularly over-under shotguns. This stage involves joining the barrels together and ensuring they meet the necessary structural and aesthetic standards. Once welding is complete, the barrels go through an extensive polishing process to remove oxidation, welding residue, and any imperfections. The worker carefully polishes the metal using abrasive materials or polishing machines, ensuring a smooth and even surface. This step is essential for both functional and aesthetic reasons. Any remaining oxidation or rough spots could impact the performance of the firearm, affecting the rifle's precision and durability. Additionally, polishing helps prepare the barrels for further finishing processes, such as bluing or coating, which protect the metal from rust and wear. The final result is a perfectly smooth, polished surface, free from defects, ensuring the firearm meets high-quality standards before moving on to assembly and testing. The assembly stage of rifle manufacturing requires expert craftsmanship, particularly in the fitting of key components. Fitters, known as incassatori in Italian, are responsible for precisely mounting and adjusting critical parts such as the side plates, action, trigger assembly, and other essential mechanisms. The fitting process begins with the stock-to-action alignment, where the wooden stock is carefully shaped and adjusted to fit seamlessly with the firearm's action. Any excess wood is removed using hand tools and sanding techniques to ensure a snug and stable fit. The fitter then moves on to the side plates, which are mounted onto the rifle's body. These plates serve both a functional and aesthetic purpose, providing additional reinforcement to the firearm's structure while also contributing to its visual appeal. To ensure perfect alignment, the fitter uses precision jigs and measuring tools. Even slight misalignments can affect the rifle's accuracy and reliability, so this step requires extreme attention to detail. The fitter also checks that all screws and fasteners are properly tightened without putting undue stress on any part of the firearm. Once the side plates and other components are securely fitted, the rifle undergoes a series of fine adjustments to ensure smooth operation. Once the firearm is fully assembled, it moves on to the quality control and functional testing phase, one of the most critical stages in the manufacturing process. This phase ensures that every rifle meets the highest standards of performance, safety, and durability before it leaves the factory. One of the first tests involves checking the trigger mechanism. Fitters use precise gauges to measure trigger pull weight and consistency, ensuring that it is neither too light, which could cause accidental discharge, nor too heavy, which could affect shooting accuracy. They also verify the engagement of the sear and hammer to ensure that the trigger system resets and functions properly. Another crucial test is the extraction and ejection test, which ensures that spent cartridges are properly removed from the chamber after firing. The extractor and ejector mechanisms are tested with different types of ammunition to verify smooth and reliable operation. If a cartridge fails to eject or gets stuck, the mechanism is adjusted accordingly. The firearm is also subjected to headspace testing, where the fitters use go and no-go gauges to confirm that the chamber dimensions are within precise tolerances. The go gauge should allow the action to close properly, while the no-go gauge should prevent it from fully closing, indicating that the chamber is not oversized.